Hey there, welcome back to my channel. Before we start, please don't forget to hit that subscribe button if you want to see more coding interviews questions. So in this video, we'll be discussing and solving the problem palindrome linked list. So let's get started. The question is that they give us a single linked list where each node has a value and next pointer, and the task here is to return true if it's a palindrome or false otherwise. So what do we mean by a singly linked list palindrome? A palindrome linked list is a sequence of nodes that read the same forward as a backward. So the first and the easy way to determine if the input linked list is a palindrome is by using a stack. For example, let's say we have this input linked list. The algorithm that we're gonna implement is that we're gonna start by traversing from the left to right, and at each step we push the current node to the stack. So since the stack follows the LIFO last in first out data structures, the last element added to the stack will be the last node in the linked list. After that, we'll start comparing nodes from the head of the linked list and the top element of the stack. So once the stack is empty or the linked list become null, there is no more comparison. So we'll return a valid palindrome linked list, which means true. Otherwise, we'll return false, meaning that the given palindrome is false. So the problem with this solution is that we are using an extra space by using the stack data structure, which takes space proportional to the input size. This means a linear space complexity and also a time complexity of O(n). So the second way to solve this problem is by using recursion. So the recursive function used something called the call stack. When a program calls a function, that function goes on top of the call stack. So this is similar to a stack of books. We add things one at a time. Then when you are ready to take something off, you always take off the top item. So let's say we have this input linked list. So we're gonna take advantage of the recursion stack of the compiler and compare the first node with the last node and the second node with the second last node and so on. So at any point in time where the comparison returns false, the result will be false, meaning the linked list is not a palindrome. So otherwise, if all the comparison return true, we get a result true, meaning it's a valid palindrome linked list. So we start by looping over the linked list from the start to the end. So once we reach the end of the linked list, we will have two pointers, the left pointers at the start of the linked list and the right pointer at the end of the linked list. Then we compare the value of the two pointers. If both have the same value, we return true as a result for the last call in the stack, and we move the left pointer to the next node. So for the right pointer, the recursive call will take care of it by moving it to the previous node, and we will repeat the same process by comparing the two values of the two pointers. So if all the recursive call return true, the result will be a valid palindrome. Otherwise it is not a palindrome linked list. So in order to solve this problem using recursion, we're gonna start by initializing a dummy node that will keep track of the left pointer of the linked list during the recursive call. Then we need to define a recursive function that is going to do all the work and return to us the result as true or false. So the recursive function gonna start by calling itself with the head of the linked list, and it's because we're not at the end of the linked list, the recursive function will move to the next node and call itself again. So the function will keep calling itself again and again until we reach the end of the linked list. So once we reach the end of the linked list, the function gonna stop calling itself, and as a result we will have two pointers, one at the left of the linked list and one at the right of the linked list. So the second step is going to be the comparison between the two pointers. So we're gonna start by comparing the two pointers and return the result to the function call that we have done before. And each time we return the result to the function call, the right pointer gonna move automatically to the previous node and the left pointer gonna move to the next node. So if all the comparison between the two pointers return true, that means we have a valid palindrome linked list. And if only one call gets a false result, the result of the main function call will be false. So the time complexity for this solution is O(n) because we are traversing the linked list from the head to the end. So n present the number of nodes in the linked list. While the space complexity is O(n) because we are using recursion. And as I said during the explanation, the recursion uses a call stack, and at every call it's create a new frame, means another space in the stack. So the question is how we can solve this problem without using extra space in memory and only using constant space memory. So the third solution going to be by using the two pointers technique, and the linked list has a special two pointers method where we call it the slow and faster pointers. So the slow pointer move one step, meaning one node, and the fast pointer move two steps, meaning 2 nodes. And the idea here is that by the time the fast pointer reach the end of the linked list, the slow pointer going to be at the middle of the linked list. And then we're gonna apply the reverse linked list. And if you have not watched my previous video about the reversing linked list, make sure you watch it before we continue this video so that you can understand how we can reverse the linked list. So as I say, once the slow pointer reach the middle, we're gonna reverse the second half of the linked list. Then we'll start comparing from the head of the second half and the head of the first half. So if both the halves are exactly the same, then the linked list will be a palindrome. Otherwise, we will return false. So the time complexity for the solution is often because we are traversing the linked list only once, and the space complexity is often since we are not using an extra space memory, only using constant space, meaning we are using only pointers. That's it, guys. So let's jump at coding the solution. So the first solution will be by using stack data structure. So we start by initializing an empty stack to store the values of the node of the linked list. Then we initialize a variable called current and set his value to be the head of the linked list. After that, we'll loop over the linked list using a while loop. So this loop gonna keep running until we reach the end of the linked list. And at each iteration, we will push the value of the current node onto the stack and then update the current variable to be the next node. So once we have added all the nodes to the stack, we're gonna reset the current variable to the head of the linked list again. After that, we're gonna loop another time over the linked list, but the difference is that at each iteration we will pop from the stack the last value of the node and compare it to the value of the current node. So if both values are not the same, we return false, otherwise we return true, indicating that the linked list is a palindrome. So the second solution will be by using recursion. So we start by creating a dummy node and set his value to be 0 and set his next pointer to the head of the linked list so that we keep track of the left pointer in the linked list. Then we define a recursive helper function that takes as argument the linked list node as an input and return a boolean value indicating whether the linked list is a palindrome or not. So we start by setting the base case of the recursive function. If the head is none, meaning we reach the end of the linked list, we return true, means it's a palindrome. So during the recursive steps, we're gonna call the recursive function on the next node in the linked list and store the result in the right variable, which represent the right pointer. Then we move the left pointer to the next node in the linked list. So after that, we check if the current node value is the same as the node value from the right pointer. If they are not equal, the linked list is not a palindrome, so we return false. Otherwise, if the linked list is a palindrome up to this point, we return true by checking that the right is true and also the current node value is the same as the node value from the right and is the same as the node value from the right pointer of the linked list. Finally, we call the recursive helper function of the input linked list and we return the result. So for the third solution and the optimal solution, which have a constant space complexity, we start by checking if the linked list is empty. If it is, we return true because an empty linked list is considered to be a palindrome. Then we start searching for the middle of the linked list with the help of the slow and fast pointer technique. So we initialize a slow and fast variable and point both them to the head of the linked list. So the slow pointer move 1 step and the fast pointer move 2 steps. Once the fast reach the end of the linked list, we then reverse the second half of the linked list by iterating throughout the second half of the linked list, starting from the middle node slow, and we use a variable called a previous, which are the pointer to keep track of the reversed nodes. Then we assign his value to be none because the last node of the reversed list should be point to none. Then we reverse the second half of the linked list by using a while loop. Then we set the current variable to be the slow variable and move the slow to the next node. After that, we set the current node next to the previous variable so that we can reverse the direction of the pointer. And finally, we set the previous variable to be the current variable so that we can keep track of the reversed node. So once the loop finishes, the previous variable gonna be pointing at the head of the reversed linked list, which is the second half. So once we reverse the linked list, we start comparing the first half with the second half. If one of the value are not the same, we return false. Otherwise, if we reach the end of the linked list without finding any difference between them, we return true because the linked list is a palindrome. That's it, guys. Thanks for watching. See you in the next video.